the trucking industry, a fraction of a cent per mile can make a big difference in your margins. Fuel is still one of the biggest expenses for a tractor, and in recent weeks, that costliness has gotten a whole lot worse. Your business should always be asking, how much more can we move with a single gallon of diesel? And the people with the answers to that question are almost certainly the guys that make the stuff that turn the diesel part into the move part. Today, we're looking at some of the specific engineering achievements that OEMs have been making to get their trucks to move more with less year in and year out. I first reached out to the North American Council for Freight Efficiency to hear what they see fleets are doing to improve their fuel efficiency. Young-Soo Park, Director of Engineering for NACME, told me all about some of the technologies he sees in the Fleet Fuel Study, a benchmarking tool for fleets exploring fuel-saving tactics.
The number one thing that probably, or one of the highest priority things I think that's helping fleets improve their fuel efficiency is the fact that the OEMs have done such a great job with the powertrains and the newer trucks.
And then I had the chance to speak with two major truck manufacturers to hear exactly how they've been able to continuously improve how much their trucks can move with a single gallon of diesel. Daimler Truck North America and Volvo Trucks North America. Daimler's Freightliner Cascadia launched nearly 20 years ago in 2007, and the flagship truck of the most popular brand in the nation made fuel efficiency a focus right from the start. Since 2007, the latest model of the Cascadia has achieved a 35% increase in fuel efficiency. The Volvo VNL was first introduced in 1996. It has made some major strides, as is obvious from the look of this picture of its 2002 exterior. Compared to the previous VNL, last updated about 2018, the latest 2024 all-new VNL has an impressive up to 10% better fuel efficiency. So how have major truck manufacturers continued improving fuel economy for carriers, year after year after year? Let's hear from both of them and split the question into two main topics: aerodynamics and powertrain. Aerodynamics. Fleets know well that one of the best ways to save on fuel is to simply spend less energy pointlessly moving air around. Here's Dwayne Teagles, VTNA's product marketing manager.
When you start looking at aerodynamics, it's a big thing. Sometimes it's thought of as a bit of a wise tale or black magic there, But essentially what we're doing is reducing the required horsepower to pull a truck or pull a load down the road. That's what we're looking at from that perspective. If you look at the amount of horsepower required just to pull an 80,000 pound load down the road in like an old long nose truck, it was about 265 horse. With our new truck, we're looking at roughly 220 horse. Now that's on flat terrain, 80,000 pound load at 65 miles an hour. That's just an example. So what that is it's a 17%, it takes 17% less horsepower. Every horse requires a certain amount of fuel to burn. They're thirsty and every one of them wants to drink. So the more you use, the more fuel you're going to burn.
And OEMs have made major strides in aerodynamic improvements. Trucks today look very different than they did a couple decades ago.
The fact that they're speccing aero truck models as opposed to long nose, flat hood, the old Texas bumper kind of trucks, those, they're still around, but most fleets now, if you care about fuel efficiency, you're not even thinking about those anymore. So you're getting the aero hood, you're getting side skirts with it, getting aero mirrors, of course.
The latest Freightliner Cascadia focuses heavily on aerodynamics for its fuel efficiency gains. This new model boasts a 1.9% better fuel efficiency over the last model, and that is thanks mostly to those new aerodynamics. Here is Greg Trinan, Daimler's VP of On-Highway Market Development.
So throughout the different generations, sometimes we update the powertrain and aerodynamics, sometimes powertrain, sometimes with that iteration, we're launching the 5th generation Cascadia in 2025. Really focused on some of the aerodynamic improvements. An all-new bumper with air ducts, again, to really optimize the way the airflow around the wheels. An all-new, hood-to-bumper seals, new wheel well covers, or new wheel well kind of closeouts, improved A-pillar deflectors, all sorts of different things like that to really continue to find and dig deep to find additional fuel efficiency gains for our customers.
On the Volvo side, the new VNL boasts up to 7% better fuel efficiency from aerodynamic improvements alone.
Yeah, so when we look at the aerodynamics of the truck, It really starts out with the shape of the truck, and I think it's pretty pronounced when you look at it. Looking from the top side of it, the front of the vehicle kind of looks a little bit like a bullet. The rest of the cab comes back almost in a wedge shape. The most distinguishing factor that I see in the vehicle is the windshield rake. We've raked it from 68 degrees to 52 degrees. And that just kind of allows the truck just kind of cut through the air.
Dwayne also mentioned that some other V&L aerodynamic improvements included placement of the cooling vents, the size of the radiator, a larger grille, closing off the space between the wheels and the hood, cab extenders, shrinking side view mirrors with the help of the camera mirror system. Powertrain improvements essentially boil down to friction reduction, getting rid of anything that stands in the way of diesel combustion and the forward propulsion that tires ultimately generate. That can mean running the engine at a lower RPM or cutting parasitic losses. On the Freightliner side, when the first generation Cascadia launched in 2007, it also marked the beginning of the Detroit DD engine platform. As the years progressed, the Cascadia continued to use the DD platform, and the platform continued to improve its efficiency. Here is Steve Collins, Daimler's Director of Field Sales Engineering.
I mean, if we work all the way back through that first launch of the heavy-duty Detroit platform, efficiency improvements along the way through each generation, just like with the Cascadia on the aerodynamics changes. There's been efficiency improvements from the powertrain perspective, and then also additional downspeeding along the way too, right? So reducing friction, increasing the efficiency of actual combustion, and then having an integrated solution like Greg mentioned to allow additional downspeeding through the selection of faster rear axle ratios, right? So over time, you're allowing the engine to do its work, to work the engine harder, but spin it slower is the name of the game for downspeeding. And the more we can do that while delivering the power and performance required for customers to do the job or deliver the load, that results in fuel efficiency.
The latest 6th generation DD engines make plenty of changes specific to EPA's model year 2027 regulations, but it includes a few efficiency boosts too.
We're also delivering enhanced efficiencies. Some of the things that we're doing on the Gen 6 engine side, introducing better airflow and air management and combustion through things like Miller cam cycle timing. So we're clocking the position of that intake cam lobe, so that during that 4-stroke cycle, we're actually leaving that intake valve open a little bit longer during the first start of the compression stroke. If you leave open that intake valve, it's reducing the amount of work to achieve compression, right? And anytime we can reduce the amount of work and still deliver power, that means less fuel burned at the end of the day.
The engine also introduced a variable output oil pump to more easily lubricate the engine. They updated its turbocharger design by adding a wastegate and bringing the efficient DD15's ball bearing design onto all the platforms. Volvo also introduced improvements to its oil displacement technology.
We've put in a variable displacement oil pump that reduces frictional resistance, gives us the right amount of oil at the right time. So idle, you're going to be right around 15 psi, and when you engage your exhaust brake, you could be as high as 50. So that changes based on the application, and by doing that, it allows us to save just a little bit of fuel.
Dwayne also said that Volvo put in a 15% shorter piston and 4% longer rod. Changing the engine geometry that way reduced friction by roughly 6%. The manufacturer was also able to get its transmission to shift 30% faster, better keeping the engine at its ideal RPM.
When you look at fuel economy, it really gets into the details. Now, every engine is a little bit different when you talk about sweet spot. Torque curves are varying, so there you got to gear them a little bit different. But if we look at like our turbo compounding engine, our sweet spot where it best runs is between 950 and 1250 RPMs. The lower you go, the more or reduced amount of pumping loss that we have in the engine. Where we get into some level of downspeeding.
And there's a lot more between the engine and the asphalt that OEMs have been looking at for further efficiencies. Everyone's into integrated powertrains these days. There are some solid improvements to fuel consumption if the engine and the transmission are designed to work and communicate together.
Back when I started in this industry, fleets were still, sort of picking components off like a menu, right? I want this engine, I want this transmission, I want this rear axle, I want that, frankly, air cleaner and fan drive and all that other nonsense, right? And nowadays, most fleets are generally buying trucks that the OEMs have engineered and with integrated powertrains, integrated components. And I think that's made a huge difference, right? Both in terms of fuel economy as well as reliability and all those things, cost of ownership, overall cost of ownership.
And there are countless other ways that speccing equipment can improve fuel efficiency, like low rolling resistance tires or more efficient auxiliary power units. But ordering new equipment is also very slow and expensive. What about fleets that don't have a ton of capital sitting around? What if I want to make a change today, not 6 months from now? NACFI's Yeonsu Park points to several practices that could make an impact.
So it takes a while to get the newest trucks, but practices you can put into place today, and sometimes with very little upfront cost or maybe even no upfront cost. The biggest one is probably the one the fleets don't want to hear, but they know, right? It's the speed reduction. Everybody knows that wind resistance is something like 67% of your fuel that you buy goes to fighting wind resistance, and wind resistance goes up by the square with speed. So anytime you can reduce that, that has a huge impact, and that'll probably bigger at least return in terms of actions versus MPG gain than just about anything else you can do.
Yeonsu also mentioned truck maintenance. Tires, belts, filters, flaps, fenders, keep it all in tip-top shape. Tweaking engine parameters too can sometimes help get a little bit better horsepower per gallon. So in summary, make sure your trucks are slicing the air cleanly, use cutting-edge powertrains when you can, and engage in practices that reduce fuel spend. But ultimately, simply caring is a big factor in fuel efficiency too.
And then honestly, it's maybe less obvious, but just the fact that you watch the fuel economy, you measure it, you report on it, you're constantly talking about it. Just doing that, even without you doing anything else, that alone has an effect on fuel economy. So, there's this phenomenon called the observer effect, right? When you watch something, it improves. That is true for fuel economy like anything else. And it's something, frankly, fleets can, if they're not doing it today, they could be and should be doing it. And that, again, has no upfront investment. You just go in and start doing it.
Thank you for watching. Check out our YouTube channel for more content like this. If you want to hear the entirety of my conversations with NACFI, Daimler, and Volvo, check out the Fleet Lead podcast. If any fleets are interested in participating in NACFI's fleet fuel study, you can always reach out to Yeonsu Park or Mike Roth for more information.